Hello everyone and welcome back to physics class. Today I want to talk to you about the resultant force. Now, when we talk about forces acting on bodies, there are multiple forces acting on any given body at any given time. What we are often concerned with is what is the force that causes this object to move? And in which direction is this in? So this force that causes an object to move is often the result of many other forces added together. And we call this the resultant force. So the resultant force is the sum of all forces that are exerted on a certain body. We often will denote it as FR, resultant force. When we talk about the sum of forces, we are going to be adding vectors. So we need to review how to add vectors a little bit. Let's say we have this force at a certain angle theta. We need to break this up into our x and y components in order for us to add the forces together. When we add vectors, we always have to break up the vector components. So our horizontal is our force times the cosine of theta, and our vertical component is force times the sine of theta. Now, when it comes to finding your FR, the first step is to break up all your forces into the x and y components. So find Fx and Fy for each force. Step 2 is you want to add the Fx together. Step 3 is add your Fy together. And then step 4 is you would use this formula here to find your resultant force. So that's the procedure when we are looking at an example where we are trying to find the resultant force acting on a body. So let's go ahead and take an actual look at an example. In this example, we have a football player is being pushed simultaneously by two opponents. If one opponent pushed with a force of 45 newtons at 72 degrees, and the other pushed with a force of 62 newtons at 300 degrees, what is the resultant force? Let's start out by drawing our free body diagram. When it comes to solving physics problems, most of them happen to be word problems, if you haven't noticed that already. And free body diagrams is a really useful tool to use to help you determine what directions the forces are acting in and what kind of components we're looking for. So let us draw our free body diagram in this case. So remember, we always start with a dot to represent the body that the forces are acting on. Now, this is going to be a top-down view, all right? So this is the top of the football player's head, and we're looking at the forces that are acting on him being pushed parallel to the ground. So this is the top-down view. So the first force is at 72 degrees, so about this right here. And then this is force 1 is equal to 45 newtons. And then the angle is 72 degrees. And then the second one is at 300 degrees, so it's going to be like this. So here we have 300 degrees, and F2 is 62 newtons. So this is my free body diagram. Now I'm going to go ahead and actually start solving for the resultant force. So step 1 is I'm going to take a look at the different forces, and I'm going to break them up into their components. So F1, x is equal to F1 cosine theta, which is 45, cosine of 72. And that will give me 13.9 newtons. And then F1y is F1 sine theta, so 45 sine of 72. That will give me a total of 42.8 newtons. Now onto the second force. So same thing, I'm just going to write out my formula with everything input into it. I calculate that. That gives me 31 newtons in the horizontal. And then in the vertical, I will get a negative 53.7 newtons. So we have this part done. Now let's move on to the second part where we are going to add up the x's and we're going to add up the y's. Step 2. So fx total is going to be 13.9, which is this guy, plus the 31. And that gives me a total of 44.9 newtons in the x. If we look at the y's, we're going to be adding these two. So fy is equal to 42.8 minus 53.7. And that will give me a total of negative 10.9 newtons. So that was step 3, really. So the last step is we're going to find our resultant force. So let's plug in everything here. It is going to be 44.9 squared plus negative 10.9. That needs to be put in brackets, squared. Now, when you go ahead and you calculate all of this, you will end up with the resultant force of approximately 117.9 newtons. Now, of course, when we are talking about forces, we are talking about vectors, and we also like to know what the direction is. So, when we calculate our direction, we have to consider the quadrant that this is in. So if we look at our values here and here, we can see that we have a positive x, but we have a negative y. So that means that our angle is going to be in this, if we were to draw the quadrants, it's going to be in this quadrant right here. So let's go ahead and calculate the angle. We're going to use tan theta is equal to our fy over fx. Now this is, of course, just remembering from adding vectors, and we are going to go ahead and type that in. So theta is equal to tan negative 1 of 10.9 divided by 44.9. And this gives us our angle of 13.6 degrees. Now remember, this is the angle that's like right here in between the x-axis and the force, but on the opposite side. We want to have the angle going in the opposite direction. So what we're going to do is we're going to take 360, we're going to subtract 13.6 from that, and we're going to get our direction of 346.4 degrees. So this is the direction that is associated with this force. And that is how you find your resultant force. Just take your knowledge of adding vectors and apply it to forces, and that's how you go about it. Thank you for listening, and I will see you all next time. Bye!